Good day, everyone. As a partial requirement of the Power System 1, I, Kiran Kudaste, will be showing to you a sample of a substation which is done through ETAP software. But before we dive in deeper, let us have a background of, let's say, what's ETAP, then why is single line diagram important, and another question for that will follow. And these are the things that we need to understand first. First is why model a power system, then importance of single line diagram, and then the ETAP software. A little background about it. Then we answer the question, why model a power system? Power system modeling is a critical aspect of the successful operation and management of electricity network. Then, planning models and software serve to provide a platform where testing can be performed and scenarios can be verified in an offline environment. Meaning, with modeling a power system, you can run through different faults, different parameters of your equipments, and see what is suited for that kind of power system. The next is operational and real-time modeling in software is primary method of interaction for control engineers in their supervisory and management role. So interaction, they can make any adjustments they want without harming any of the system because it is only run in virtual. Then the importance of single line diagram. Power system designers should always communicate their design requirements through a combination of drawings, schedules, and technical specifications. One of which is the single line diagram. That is why it is very crucial for communication of the power system designers. Then starts with the incoming power source from the utility service or on-site generation and their associated distribution equipment, meaning power line this single line diagrams starts with the incoming power source from the utility or from the generation. Then it follows the power flow down through the various conductors and the loads. Then here are single line diagrams provides a framework for the incorporation of different types of required information such as incoming service voltage and utilization voltages required. This can be seen in single line diagrams. Then electrical distribution equipment, ampacity and short circuit ratings, overcurrent, conductor types, cable lengths, and etc. Now for the final background that we need to know is the ETAP software. ETAP software stands for ETAP stands for Electrical Transient Analyzer Program. It is a powerful tool to do modeling, simulation, and analysis of power system. It provides a platform to electrical design engineer to model a power system starting from source to load. Then after modeling the system, one can simulate various kinds of faults like how we explained earlier that it is why single line diagram are important and why is there a need to model. This ETAP software helps us model a power system so that we can do different adjustments on the equipments that will be used. Now I will be opening the ETAP software. I want you guys to focus on the screen. This is the ETAP software that I was able to download and was able to do a model of the substation. And since I have already created, I'm just gonna open the file directly. So as you can see here, this is the sample of a power system. that the one line power system that I was able to copy from the internet, and it starts from here, from the utility supply down to bus 1, then our first circuit breaker, then the bus 2, then our transformer, then bus 3 cable 1, the another breaker at the bus, and breakers for both feeder. These feeders are identical to each other, same load. I was able to create this diagram by following the how the diagram looked, and I was fortunate enough to have gathered information about the diagram, or more like information on each of these equipments used, which is very crucial for running different faults in this diagram. And I would like to show you the data that I was able to gather or was able to obtain. So for the utility equivalent, these are the datas that I inputted at the diagram. Then here is for the transmission line, the the transformer, the cable, and the feeder loads. The utility supply is the topmost in the diagram, and when we look at how it was set, it is in three phase. Then here are the ratings, and the short circuit was this data, this XR ratio is from the data that I was able to obtain. See here, there's a three phase fault and a single line fault, and these are its XR ratio along with the 230 kV as its utility nominal voltage. So it was set here, and after this XR ratio were input, ETAP directly calculated this MVA and the impedances as shown here. I did not do any calculations. ETAP did it for me. Then the next will be this transmission line. The transmission line was set here in the data as 0.10 miles and a Pelican type. This Pelican type is right here in the choices, right here above this here at the cursor, and there are many types, but then at the data I gathered, Pelican type was used, so I used Pelican, and a 0.1 length in transmission line in miles. The next will be the transformer. The transformer is a two-winding transformer that has its rating at 230 from the primary, and at the secondary is 13.8. It is also here at the data shown here, 230 and 13.8 with a 100 apparent power, then 10% impedance, and XR ratio is 34.1. After these values were input, directly the impedance is solved by ETAP. The next is the cable. For the cable here, it is said that its size is 750 kml and 300 feet. Conductors per phase 12, rated voltage 15, and the aluminum type. Those were easy to find since to be able to input those, you have to go to this library, and then you have to specify what type do you want. So here, this AL stands for aluminum. So select unselect all, then choose aluminum. Then next, this KV, it's 15, it was 15. So I was able to find it easily. So in the next one, we have the feeder loads. As shown in the diagram, there are two feeder loads which are identical to each other. So just have to copy paste the first. But the input here is 13.8 and 0 with 0.8 load power factor and connection in delta, which is already placed here already here in the nameplate. Okay, now that our diagram is set, we are to test it to see if it is working. And to test it, we are going to do a the ETAP software will perform a short circuit calculation, and all you have to do is press this lightning symbol here, short circuit, and then you have to go to this briefcase to select which bus you will you will put as faulted. So we can choose bus 1 to be a fault to be at fault, then okay, and then press this lightning with a max. As you can see here, it's a 3-phase, which is the maximum short circuit current. Then if you press that, values will come out shown here. 0 kV at the bus where it is faulted. This is bus 1, and as you notice here, the arrows are all going to the bus that is faulted. This is what will happen at short circuit, where the faulted part kinda sucks in all the currents. And to do another example, we can do we can also add the substation fault and see what happens. Now there are two faults that will happen. Let's see. And there we go. This here, this is the first fault at bus 1. As you can see, the current is still being sucked there. Then also in this substation bus, where the feeder loads also provided some current. We can also add we can also test short circuits at individual lines or bus, and to do that we just have to use this part here, the star protection and coordination. But in order to use this, we must first set protection, system protection, which is the essence of this class of summer 2023. And to show you, I have already created a system with protection. Let me just open this at the file, and then this will be the same substation diagram, but now this substation diagram will have protection. This is the system with protection, which is a differential relay connected to current transformers. Here CT1 and down here CT2 for this first relay, and the second relay still a differential transformer connected at CT7, CT3, then CT5. We will see how the protection will happen if there is a fault that will occur. But first, we should press this star protection and coordination. Then, after that, we get this lightning here, fault insertion here. We could place this at any part we like. It could be here. Let's try it here. And that is what's going to happen. First, the circuit breaker 1 trips, and then followed by the circuit breaker 2 here. We can see the sequence of how everything happened by looking at this table here, which states that the T1 relay, this one, T1 relay, activated at 20 millisecond 87 differential and tripped by T1 relay as shown here, T1HS breaker, the first one here, and the M1B breaker is tripped by the T1 relay phase. So that is what's going to happen if a fault appears when there is protection at the system. So next we can transfer the fault. We can easily transfer the fault by dragging it to another location at here, for example here. Now if fault happens there, the sequence, what happens is that this T2 relay, this T2 relay here below trips the F1 breaker, the F2 breaker, this one F1 breaker, the F2 breaker, and then the M1 breaker, which is included in its protection. So that's what would happen there. Now let's see what happens if we place the fault here. So as you can see, the three breakers were activated. And then the T1 relay and T2 relay were activated. T1 relay tripped the T1 HS breaker, which is at the top, and then T2 tripped F1 breaker and F2 breaker along with M1 breaker. And the same with T1 relay, it also tripped M1 breaker. This is the M1 breaker, which is included at the zone of each relays. A set of relays here, the two. Now if we move the fault here outside, we can see nothing happened because this is a differential relay, and it looks like that whenever fault is within both its relay, it will trip, but when it is outside its protection, it will not trip. So this seems like it's missing a zone 3, like from the class that we have discussed. So when it's outside, it's not gonna trip. Now no relay is going to detect a fault, but if it's inside, then here, as you can see here, T1 relay detects a fault, then trips T1 HS breaker and M1 breaker. But if we place another set of protection, like the pilot and non-pilot protection, which has zone 3, it will be in another case. But for this video today, this will be the zone of protection I am going to show, which is a differential relay zone, is differential relay protection. And we saw how it protects the system and what are its disadvantages. So that's all for today. Thank you for watching.